So today we're going to work on finite state machines. So I'm going to take a different approach to this than most people do. I'm going to take the bad code that I've been working on for the last few videos, and we're going to turn that into a finite state machine, and hopefully you will see how it can be better. Now this tutorial is going to focus for beginners to understand the core concepts of how finite state machines work, opposed to really making a really polished end result. There are some more examples on YouTube that I will recommend you go and watch after you watch this one, and hopefully this will give you a little bit of the basics to understand what they're doing more. Because most people want to put their best code forward, but in this case, for beginners, the finite state machine can become pretty unwieldy very quickly because there's just so much to keep track of and so much code. So just so you know what's going to be in this video, we're going to quickly go over the bad code, then we're going to do a first draft going over the basic concepts of what we're trying to accomplish, and then we're going to do another revision where it's going to hopefully make the code and the project much more readable and accessible to other people and yourself. And then afterwards, we're going to take a look at another example of a finite state machine that I've written for a different game that has a lot more of the bells and whistles, and will hopefully show how much more complexity this framework can handle. So just a few things to remind you about from my last videos are that we have a whole bunch of areas keeping track of where the player can go and what's going on. We have a whole bunch of signals that are connected to the player script, and in that player script, we have a whole bunch of these booleans that we're going to toggle back and forth to be true or false. And then when we are moving, we're going to check those variables to see if we can actually move. So to move to the right, we're going to check to see if we're on the ladder, and then we're going to see if we're on a bridge, and if we're not, we're going to see if there's water. That way we can actually move off of the bridge. So these all have purpose and it works, but there's a lot of checks that are happening over and over and over again. So like I said, we're checking to see if we're on the ladder here, but we're also checking to see if we're on the ladder down here and here multiple times, and then we finally decide if we can move. Now, these are all necessary for the different situations that I have. I wanted to be able to move, but not go into the water on the bridge, but then also collide with the water. And then on the rope, I wanted to be able to only climb the rope from the bottom, and if I was on the rope, I didn't want to collide with the water. These are all extra checks that you run through every frame. Now, like I've said in the previous videos, if you didn't have quite so many checks, this framework would be perfectly fine for a simple game, but this is getting pretty cluttered and just unintelligible to read. So the first thing that we're going to do is we're actually going to split the movement logic into different functions based on what the player is doing. So if you're going to walk, you're going to do these checks. If you're going to climb, you don't have to check for as many things because it's pretty simple. We don't need to check for water. And we're also going to have a function if we're walking on the cliff. So in the old script, if you were going to climb a rope or a ladder, you would check to see if you were on a ladder for going left or right, and then you would check to see if there's a bridge, which is completely unnecessary because you're never actually going to interact with the bridge while you're climbing. And then we're going to check to see if you're on the ladder again, and we're going to check to see if there's water. So the reason why you need all these checks is you don't want to be stopped by water, but we are literally checking for water and then checking to see if we are on a ladder to see if we don't need to check for the water. And it's kind of silly. It's just going back and forth over and over again. And if you add any more complexity to this, it'll just be completely garbly goop. Going back to our first draft, this is our climb function. Now we're going to have three different functions in this draft, and we're going to have just a basic walking function, or walk. Then we're going to have climb, and then we're going to have walking on the cliff. So the most complex one is because of the bridge. When we are just walking, we're going to be checking for the bridge and checking for the water, because I want to collide with the water, but not if I'm on a bridge. So when I'm walking on a cliff, I'm never actually going to have water or bridges up on the cliffs, so all I have to do is make sure I don't walk off the cliff. And in each of these functions, we're going to move and slide, because we only run one of those functions each frame, and we choose it by having different states. So these are the states that are available. We're only going to have 3 for this example, and we'll have more in the future. But we're going to have a current state. Then we're going to run a match statement. If we are currently walking, if we're just on the ground, we will run that walk function. If we are climbing, then we'll climb, and then if we're walking on a cliff, we'll walk on a cliff. Now, how we switch between these currently would be the ladder check. So that area 2D that checks to see if we're getting onto a ladder or off of a ladder. We're going to change the state, which is just a little function that all it says is we're going to send it the new state and set it to that state. So what this is saying, this is the body entered. So if you enter a ladder, if it's the bottom of the rope, then we will change the state to climbing. Now the top of the rope has a few extra checks just to make sure you don't climb onto the top of the rope when you're walking behind the cliff. When you're walking like this, you don't want to be able to get onto the ladder from behind. If you enter the top of the ladder and you are not on top of the cliff, it'll ignore it. And then we will change the state to climbing. So when you exit a ladder, we're going to check to see if you are currently climbing, because if you are behind the cliff, you don't want to be able to trigger this by just walking behind the cliff. But when we exit, if we exit at the bottom of the rope, which is vector 0, 0, we will change the state to walking, and if it is the top of the rope, we will change to walking on the cliff. If you don't understand how these checks work here for the tiles, I will leave a link in the description for my previous videos. So to wrap it up, based on if we're entering or exiting the ladder, we will change from walking to climbing to walking on the cliff, and based on which one we are currently in, or our current state, we will run the walk function that does this logic, or we will run the climb function, which is simpler, or we will run the walking on the cliff. Now this ends up with more code in all, but actually running less code each frame, particularly when you're climbing. I think that's the easiest example to see, that it runs significantly less code when you're climbing because there's not much to actually worry about. So in this next step, we're going to make this hopefully a lot easier to see what's going on. So instead of just having an array with the different states, we're actually going to add them to the scene tree. So when somebody that has never seen this before can instantly look at the scene tree and say, oh, these are all the states that the player can be in. Instead of just having a function that contains it, we're actually going to write a separate script for each one to hold all of the code. So to explain what's going on with this tree, these are all just simple nodes, and they are just acting as containers and labels, basically, for our code that we're going to run in each state. Instead of having a move function, we're going to have the walking script. And in here, this is all of the code that we will run. But none of these scripts will run unless it is told to by the player script. So this is the script that's going to keep track of all of the checks, and then it's going to delegate to which script down here gets to run, and only one can run at a time. So instead of having an array, we're actually going to use a string, which I'll show why in just a minute here. It's very handy, and we're going to connect each string to the corresponding node. That way we can access its script very quickly. We're going to update the state with a variable, and we're going to current state dot handle input. Now handle input is going to be a function that's going to be in every single one of these, and it will either return nothing or null, or it will return the new state. If there is a need for a change in the state, we will update it with these couple lines here. And again, this change state is just a simple function to change the current state variable to the new one. And when you're working with dictionaries, this new state will be a string. So it'll be like idle or walking, and then it will give us this path. So if you were to print this, what you would end up with is it referring to this node, not this string. So looking just simply at the idle, which is the easiest one to look at, if you remember, we are running this function, and we're seeing if it will return anything. So what we're going to do is we're going to loop through all of the directions, and then we're going to see if there's an input in any of those directions. If any of these are true, we will return walking. So going back to the player, what that information is going to do is it'll go here. Like I said, we ran this. If there are no buttons pressed, this will just be null and it'll just move on. It'll just be done. If you do press a button, this line right here will return the string walking. So then it will update the state to walking, which means the next time that this goes through on the next frame, it's going to run the current state or update the state, and it's going to run the handle input in the walking state. So let's go to the walking. And it's going to ask if there is an action pressed, and if there is not water, so we're just going to check to see if there's water in this state to run into, it'll do the appropriate direction. Now, at any point, if there is no input, and it's just an empty vector2, will return idle. So if it does return idle, it will go back to the player, and this will return that string, and therefore it will update here in the change state. I have more states here than in the previous example because I thought I'd show more flexibility in what you can do. So now, just to be thorough, I still have all of these checks for the movement, and when you run the handle input, like I said, when you're walking, you're going to send along the information that each script needs. And what I mean by that is the host is going to be the player. You're sending self along. That way you can access all of these variables. So if you think about it, this script kind of holds all the information, and then you're just branching out to whichever script holds the information. Like I said, you could just have these be a whole bunch of functions at the end, but I think it's a lot clearer when you open up a project exactly what goes on when you have them all in the nodes over here. So all of these scripts over here are really just extensions of this player script, but you pass this information on to each script. That way it knows where to find these variables. So like I said, when you send this function, you send self or the path back to the player. That way when you have idle and you need to check whether there is water to the right, you can just click host, because this is the same spot that the self was in the player script. And delta is just delta, so it knows the timing. Now, I still have all of these checks going on, and actually I had to add one for checking to see if you were on the bridge to trigger whether you were walking on a bridge. And the reason for that is there is different code for walking on a bridge than just walking. If you remember, when we're walking, we're checking to see if there's water to the left or water to the right. And on the bridge, we are checking to see if there is a bridge and or not water. And the reason why we have this or not water is so you can actually exit the bridge. You can get on the bridge and move around. If you don't have this or not water right, then you won't ever be able to leave the bridge. So typically in a state machine, it's best to keep how you travel from one state to another in each node. The path from this walking script to the idle script should be very clear to how you're moving. And so these changes are based on what you're pressing and what buttons you're pressing, but I've also added some signals based on where you're entering. So this is a connection of a signal from the on bridge signal. We have a body entered. So when we collide with the bridge, it knows to switch to that logic for just the bridge and not for colliding with the water like it is here. So if we follow this signal, we go to the walking script. When you enter it, when you enter a bridge, the player node changes state to walking on the bridge, which will lead us to this script. So then it'll run this code while we're moving, and then when we exit it, the player node is changing its state to walking, so it's going right back. Now, you're probably wondering where this player node comes from, because it's obviously not a built-in function. So I'm also using inheritance. So when you look at my scripts, I have my player, and then I also have my state machine. And I have a template that all of these are based on, and this is mainly for building more functions into the template later on. But something else that you also can do is you can have a variable that's going to be shared with all of these. And I strongly encourage you to use comments to explain it if you want to use this method. But when you have an inherited script, you can make a variable, which I'm going to set with the ready function with this here to get the player. This player is in a group, and it's the only player in the group. I don't ever have plans on making this a multiplayer game. So you can actually use that player node from the template. Now, just to show an example of how to set up this inheritance, I'm going to actually create a new node. Like I said, it's just a simple node. We'll call this fishing, because at some point I'm going to want to be able to fish. And when you add a script, instead of inheriting just a node, we're going to go here to our state machine, and we'll get the state template. I want this to be in the state machine also. And now in this script, it's empty right now, but I will be able to access that player node variable. Now in the template, if I actually had any code in here, if you write a new function that's the same name as the template that you're inheriting from, it will overwrite what's going on here. So if I had this be like print hello, it would never actually print hello. Because what's happening is when you have this idle and you have a handle input, it's overwriting what's in the template. Now the last one, we had all of that code for entering and exiting ladders, and we still have that code. And this is actually in the player script. I am going to change the state from whatever I am doing to climbing if I enter a rope. If I enter the top of the rope, I'm going to make sure that I'm actually on top of the cliff. And if I'm not on top of the cliff, then I'm going to return, which just ends the function immediately and it won't run this code. Otherwise, if I am on top of a cliff, I'm going to change the state to climbing, and the opposite is true for exiting. I'm going to make sure that I'm actually climbing. Again, if I go behind the cliff and go through the rope, I don't want to run this code. I want to only run this code if I am currently climbing. And then if I am at the bottom of the rope, I will just go to walking. If I am at the top of the rope, I will go to walking on the cliff. And then, just to show you that it's different, when you're walking on the when you're walking on a cliff, you aren't running any of the code for the water or the bridges. You're just checking to make sure you don't run off of the cliff. You're checking to see if you are going to be idle. And then the only way to actually get off of a cliff is to get back onto a ladder, which will be that area check here, where you have to make sure that you are walking on a cliff, and then you will go to climbing and you can get back down. Now, the reason I have this in the player script is because I don't want to have it rooted. I don't want to have a signal pointed at two different directions, and so basically I'd have to have this code in the walking and in the walking on the cliff, and it would probably run the code twice. And I just thought the easiest way to deal with it currently, I might change it later, but it would just be to put it in the player function. And then in walking on a cliff, like I said, I made sure I had a comment to explain how I'm changing out of the state. Also, I apologize if you're following along with your own project like this. If you noticed in my previous, I didn't have these all snake case, and I've decided to just go to snake case because I like it better. I don't know what I was thinking when I was writing this the first time, so I'm trying to update all of my scripts to be snake case. So now just a quick look at another state machine that I've made in the past. As you can see, you can end up with a lot of states, but you can end up with a lot of control over exactly what your player can and cannot do, and make it very easy for debugging, because if there's something glitchy when I'm crouching, I know that it's in this script. How this player works is, again, you have a dictionary of all the states that you can be in. So if you take a look at one of these scripts, this is the walking script, you can see that this one has a few extra functions in there, such as enter. And the reason why a lot of people add extra functions is I only want to run the enter one time. So it's not like the update, or I think I had handle input last time, where you run it every physics frame. I just want to run the enter one time and set the animation. And then in this one, I actually have the input mostly to show how I'm going to switch to different states. And then this is going to update all of the physics and how my player is going to move. And like I said, each one of these has slightly different characteristics about it. Because when I'm walking, I want to be walking slower than when I'm running, or when I'm sliding, or when I'm crouch walking. And those are all different speeds. And what you end up with is you can switch back and forth between all of these different states. So if you have any questions about these state machines, there was a ton of information in this one, and I'm sure I missed something. But state machines are pretty daunting. They take a lot of time to track exactly what's going on, but in the end, they can give a ton of flexibility to your game that is super worth your time if you can figure them out. So I highly recommend that you check out other people's state machines on YouTube. I'll put a couple links in the description.